So in the next half hour, I'm going to talk about Qt commercial, Qt in general on integrity. Integrity is a separation kernel, and I'll explain what that is, and I'll also go in detail on well, who is Greenhills, what is integrity, and why is it somewhere relevant to some of you maybe. We're not trying to replace Linux. Linux is a great OS, but in some particular cases, integrity is needed. Why actually Greenhills needed Qt on integrity as well. And then the history of Qt on integrity and digging a bit into the technical details because, well, I've seen a lot of interesting things in the Qt source. Right, so a little bit about Greenhill Software. So it's a 29-year-old company based in California. I'm personally based in France, but the company started in California. I don't know if you can read. Yeah, you should be able to read over there. We started doing compilers. And so we're somewhat known for making good compilers. And then about 15 years ago, we've been asked by some company in the avionics market to build up an operating system that would be, at the same time, absolutely safe and absolutely secure, which in their terms means that it's capable of running in the cockpit of an airplane and to transmit at the same time to show map display, even maybe have some limited connection to the internet and have some command coming from the radio tower. So that's really absolute security, absolute safety. It took us some time, but we managed to do what is called the 0178B Level A certification, which means it's actually capable of being deployed in that kind of system. After doing that very hard step, we actually found out that other industries needed other kind of certifications, but they also needed safety, just in another flavor. And so we've passed all these certifications, and we found out actually these were much, much easier. So all in all, now we have a full-featured development environment to build an embedded device, starting from the compiler, the debug environment, the project manager, an operating system, on top of the operating system, some middleware, and Qt for the graphics. And well, on some hard architecture, OpenGL as well, and then Qt on OpenGL is in the works. And well, at the lowest level, we have debug probes, JTAG probes. So you could ask, why should I even care about that? Linux can work in most of the embedded devices, so I could use Linux. Yeah, OK, fair. So some of our customers, let me give some examples and some actual examples of customers using Qt on integrity. I cannot give names, but I can give what they do. So a good example is a hard monitoring device with actually some display of the hard monitoring on it. Because it's not only hard monitoring, but it's also driving some of the device actually measuring on your heart. You don't want that to fail. You wouldn't want your heart to fail. So you don't want that device to fail either. Another good one is a device that actually controls what they call medium voltage, so 100 kilovolts electricity lines. And likewise, it's a classic 19-inch rack that will drive the electricity lines, and it's capable of burning the wires. And at the same time, you need a display to show the information of the capture of the current state of the device. And there, well, again, Qt allows to build something interesting. But these devices have to be absolutely secure. So in the case of, sorry, absolutely safe. There's a difference between safe and secure. So in the case of that electricity device, what they follow is the industrial automation safety, so IEC 61508 SIL 3. It's a lot of documentation, a lot of testing, and a lot of showing that you've done the right thing in your device, and you actually have looked at all the risks of malfunction. Now people will do that in industrial devices. There is another one for railway transportation. There is another one for avionics. There is another one for automotive that's called 26262. And for medical, they have an approval process, and there's a certification called 62304. It's a lot of acronyms, but the idea is the same. Look at what could go wrong and design a system that can actually prevent that by design, or if it's not possible, detect that and act on it. And that is what we have achieved with integrity. The last element, but not the least, I mentioned security. So security is not ensuring that everything works fine and, well, we can detect a malfunction. It's going the next mile and proving nothing can go wrong. If any of the applications goes wrong, there is no effect on the system whatsoever. And that means another application cannot actually steal some data. It's about data security. It's about system security. And so we've proven, we've done a semi-formal proof of the OS using interesting mathematics and a model of the operating system, penetration testing, and so on. And that's the EAL6+ high robustness type 1 security. So this one is really peculiar, and it's unique in the world. Integrity is the only operating system to have actually accomplished such a certification. The last one is not the least interesting either. We have passed the certification suite for POSIX. So I can tell you that Linux is not POSIX compliant. There are a number of elements where it is clearly not POSIX compliant. It wouldn't pass that test. And again, because our customers care about code quality, they care about stability, they care about safety, they care about security, we've passed the certification for POSIX to prove, well, that everything that the POSIX API we support is well defined. And we just use part of that POSIX API to port Qt. So what is it that makes integrity interesting? Integrity is a microkernel. So on that microkernel, you can have real-time applications, you can have safety-critical applications, you can have security-critical applications. Turns out that very often safety-critical is also real-time. It turns out that many times the graphics could be considered something real-time because it has to display at a fixed pace, and it has to be fluid. Same goes for network. If you want to have a high throughput, sometimes you will insist on having actually a good behavior for the network. Because it's a microkernel, no component, if possible, it's really flexible, but no component actually will run in supervisor mode. So that means every middleware piece is actually an application like any other. The TCP/IP stack is an application. The file system is an application. USB stack is an application. Drivers are applications, and so on. Qt is an application. And then the last step that we do now is also virtualization. Looking at the fact that actually virtualization is just putting an operating system in a sandbox. So it's just running an operating system as an application. So we just extended from, okay, let's do real classic applications, and let's put an operating system in that box. So you can have Qt on Linux, or Qt on a virtualized Windows, and also have Qt on a classic, more safety-critical, more real-time native on integrity. But there are many use cases for that. In the automotive world, for example, you could have the center stage, the center multimedia system, actually showing a Linux with all the multimedia middleware you would have on Linux. There's no point in trying to redo this one. Linux does it great. And so you can have Qt with OpenGL, with a nice GUI, and then at the same time, from the same CPU, have a Qt application for the instrument cluster. Anyway, so these are just applications. If you want, you can do bad things as well. You can put applications in the kernel, but that's bad. All right, so we needed Qt on integrity. Why? Well, first of all, there was no, and there is still no standard GUI on integrity. We have multiple solutions going from the low end 150 kilobytes GUI toolkit up to an OpenGL stack and Qt and multiprocess installation. Likewise, at the time, there was no comparable toolkit available, and in my opinion, there is still no portable toolkit that compares to Qt. And why do we need that? Well, our customers were asking for that. That's very easy. And because the market is demanding rich graphics, the market is, whether you do a tablet or a medical device, people still expect that the device will look nice. Just blocks are not enough. You want something that looks nice. And so, even for safety and security critical device, people care about the look and feel. So Qt is great there. Next. All right. So, no, I think there's one back. All right. So the timeline. So it comes back from 2006, where the initial customer who asked for Qt, at the time it was Qtopia Core, to run on integrity, paid Trolltech to do the port. And so I want to thank Harald Fernagel for doing the original port, and it took him a bit less than 3 days. Oh, here he is. So thanks, Harald. He did the original port in around 3 days. And that was great. So it proved that the POSIX API on integrity was good enough to at least get Qt running. And so it was delivered to a customer a bit later. And then, well, there wasn't any significant demand for it, but we still maintained that because we found that's a great toolkit to do demos, to show whatever we want to see, to show as a real-time element on integrity. How do you actually show the real-time behavior of an OS? You still have to have a GUI somewhere. And so Qt is a great tool for that. In 2010, I was the one to maintain that port during those years. Then with Qt becoming even more open, I added the Qt integrity branch on Gitorious, so you could actually get Qt for integrity from that branch, and it still exists. And then a few months ago, it was merged into Photodate. So when you take a Photodate release, you can actually compile and configure Qt for integrity in standard. I'll explain a bit later the reason for that, but DGI is now able of actually supporting commercially Qt commercial on integrity. So if you want to use the LGPL version, you're free to do so with some interesting legal constraints. If you want to do your closed source application on integrity, you can use Qt commercial from DGI. So I'm going to talk now about a little bit more technical stuff on the challenges that we found during the port of integrity and the bugs we found, both in Qt and in the Greenhills toolchain and even integrity, because that's a fair piece of big real-life code. And so there are things that can go wrong. The first thing is Qt is portable. So it's been tested on already a fair list of compilers. But there are a number of places where there were a lot of GNU, what they call GNUisms, so places where the code was still expecting to have GCC. And it turns out that Visual Studio also supported those extensions. The Greenhills compiler is actually a bit stricter than the average. It's very often, actually it happened to me once for the 9 years I worked at Greenhills, then compiling third-party codes with our compiler did not raise a single warning. Every time we find warnings, even in classic benchmark codes. The compiler also tries to be clever. We started doing compilers 29 years ago, and we keep doing a good one. We believe we have the best compiler in the world. That sounds really American, but we like to prove it. And so the last one is the language is always interpreted differently by every compiler. So that's true for C, and that's even more true for C++. So everybody has a different coverage of the C++ language, and sometimes there are undefined places, and so it's covered differently. And the last element, so getting the source compiled is one element. The other part is how do you actually make it behave and display on something and interact with the user. So regarding the OS layer, the easy one is POSIX. There could be actually better performance by not using the POSIX API, but it would be a lot of code to maintain. Likewise, for graphics, the easiest is to get a frame buffer, so you just render to some area of memory, display to send to a display, and you're pretty much done to draw something. Actually, that's also interesting because for safety customers, it may be actually better to use the frame buffer and not use GPU acceleration, because the GPU could do incorrect things. And then, well, the input devices. Another element is that people working on and using Integrity, developers, customers using Integrity, are used to the multi-Greenhill environment. They are not used to using makefiles to compile. And so Qt by default uses makefile. So I had to extend the QMake tool so that it would actually generate GPJ files, which Integrity customers are used to use. It was interesting because QMake is a highly undocumented element. But the code is self-readable, so it was fine. So if you're familiar with the Qt source, well, you can see this is basically creating a nice tree of all the libraries, like the core lib, XML network, SQL, even WebKit you can enable. And then all the examples, all the demos that are actually accessible from a single tree. And then it can work also for your own applications. So the end result is that you get a pretty integrated system. Another interesting block is that the initial port was done on Linux, and the configure script on Linux is very nice, and you can use it and configure and generate all the project files. However, on Windows, the configure script is unsupported. So I actually managed to run it with msysgit, so not Cygwin, but the other flavor of a Unix shell. Or you can just generate the project files on Linux and then copy it to Windows. And that works as well. And that's what the initial customers actually used. So we started from 5 years ago with no standard API for GUI and input, because simply we didn't have any on Integrity. And we created that since then. So actually, that's a classic embedded demo application, but the capture was done on a real device running on Integrity. And you probably cannot read, but that's a classic patient monitoring demo. So now you have a standard frame buffer API, audio API, input API, and so there is a single port of Qt on Integrity, and it's been tested on ARM, Intel, PowerPC, MIPS, runs on basically all architectures for where Integrity can run. Single core, multi-core, doesn't matter. And many of the examples that you can find actually have been ported as well. So in the DGA booth, there is a demo with Integrity showing an automotive one with Qt Quick. So details, interesting details. So we found a few bugs in the compiler. Actually, Qt managed to crash the compiler, but we solved that since then. Still, when you compile Qt today, there are a lot of warnings that remain. And so we're trying to do merge requests. So as part of the community effort, we are pushing merge requests to solve all these warnings. And most of them are, well, actually benign code. It doesn't affect the behavior of the system. It's just, well, sometimes there's dead data because the data is only used when you run on Mac OS. Or sometimes you've got functions that are only used on the Windows platform, and there is the if-def around is not clean. So it's a lot of little pieces that are actually not really making the code dirty, but there are things that you could improve there. So nice examples. Actually, the top one has been resolved in 4.8. It was an interesting one that was documented that you want to use in the while loop the equal sign. So there is a side effect, and it was a voluntary side effect in the while loop. So that's been done. The last one is a very good example of, well, dead data. Nobody cares. But if you want to make Qt smaller, that's one of the ways to do it. Just remove dead code and dead data. And so again, we're working that to remove and to clean that up. So, all right. So let's consider that you want to use integrity, and so how does it go? How do you develop for Qt on integrity? Well, the first step is actually a step where integrity is not in view there. What you have to know is what's going to be the size of your target screen. You can tell your designers, well, that's going to be the constraint, and maybe you can use OpenGL, maybe you cannot use OpenGL, like the library constraint, or the feature constraint, but then people can design on Linux or Windows. That's one of the great things about Qt, is that it's portable. Then, in parallel, very often, the people from the real-time, so some other people in the team will concentrate on building the drivers, on building the real-time aspect of your device, and they will build a base system. So when they are done, or when they have progressed enough doing that, you can have a gateway and communicate over the network. Again, network transparency for Qt, and the fact that the Qt network classes are available is great for portability. And then once this is done and both sides look good, well, you actually do the port of Qt to integrity, you recompile for integrity, and so far I've not seen any issue with that. So it just works. And then you can decide to keep the network communication with localhost, or you can decide to make it a shared memory or IPC, whatever mechanism, local mechanism you want to communicate between your real-time application and the graphics. Network can be done if that's the quickest way, but then you can do better ways. So the good thing is with that kind of development process is that the designers do not have to know the details of integrity because it's overall portable. So the end result, Qt on integrity is available today on all the architectures that integrity supports. You have frame buffer by default. You can have OpenGL in a few days when I find a few hours to work on that. Touchscreen input, USB, mouse, keyboard, custom input API depending on the hardware you have. And if you don't have any screen, you can use VNC. Actually, we have a customer looking for that on a network device where they want to have a remote screen. So they want VNC. So you're free to use the open source one. Again, legal constraints. Or you can use the Qt commercial distribution that is supported by DGA. And, well, again, that's one of the proofs that Qt can run everywhere. So that's really Qt everywhere. All right. Yeah, well, thank you. That's the presentation. So questions are welcome. No question? All right. So it was boring, or I said everything. All right. Well, thank you very much.